At the end of this episode, we will create this application. This reduce index is parallel algorithm using C++17 parallel algorithm. C++17 parallel algorithm. And this part is using Intel threading building block parallel algorithm. Intel threading building blocks parallel algorithm. And this part is OpenCL C++ interface. OpenCL C++ interface or C GUI syntax. I click this button, so our application is built. This is Qt GUI Application. This message comes from this line. 55 is evaluated using C++17 parallel algorithm. This parallel sum comes from here. This sum is evaluated using Intel threading building blocks parallel reduce algorithm. And this message, device vendor, Intel Corporation, NVIDIA Corporation, comes from this line of code using OpenCL C++ interface. If you check out compile output, there is no warning, no error. At the end of this session, we will create this application. And by the time you watch this video, you can click this link and download the complete source code. Hi everyone, my name is Thomas Kim. Today is January 15th, 2020. This is the first episode about Qt GUI Toolkit, Microsoft Visual C++, Intel Threading Building Blocks, OpenCL C++ interface, and modern C++ library extensions. All these tools are from different vendors. In this episode, we will integrate all these tools to make them work seamlessly. Today, we are literally making a new history for modern C++ programming. To follow this episode, you have to watch my previous video and you should have installed these tools on your machine. Otherwise, you may not be able to follow my current session. We will first download the C++ library extension. Please note that I updated this library today. Please double-click this link and download the C++ library extension. Show in folder, unzip it. Copy the folder. In my case, DevSoft. I will create a folder here, CppExtensionRoot. Then I will paste the folder here. Double click this link, double click it, copy the path, right click, search, environment, click this button, environment. We will create a system variable, click new, paste the folder, CppExtension dir. Hit enter. So we created this system environment variable. Now we are creating Qt MSVC path. Copy the path, click new, paste, browse directory, this PC, C drive, Qt, this folder. Click OK. Now in File Explorer, C drive, Qt, Tools, QtCreator, bin, copy this folder, copy, semicolon, paste. Click OK. we created this system environment variable. Now we are making this system environment variable copy, new, paste, browse directory, this PC, system, program files x86, IntelSWTools, compiler and libraries, Windows, redistribute, Intel, TBB, BC14. Click OK. Now in the File Explorer once again, System, Program Files x86, IntelSW, compiler and libraries, Windows, redistributable, IA32, TBB, copy this folder path, copy, semicolon, paste, click OK. Now we created the Intel TBB path, Qt-MSVC path, CppExtension dir. So we completed up to this point. Now click OK. Click OK. Please note that we have to reboot our system. After making changes to system variables, we have to reboot our system. This episode continues after rebooting my machine. I just restarted my machine. Now we will set these variables. Setting these variables is pretty simple. Right click, search, environ, click this link, environment variables. Now we are setting user variables. Click this button, TBB dir. Click browse directory, this PC, system, program files x86, IntelSWTools, compiler and libraries, Windows, TBB, TBB include. Click OK. Click OK. So we set this environment variable. Now click New, TBB, lib, x64. Browse directory, this PC, system, program files x86, IntelSWTools, compiler and libraries, Windows, TBB, lib, Intel64, select this folder, click OK. Click OK. Now click New, TBB, lib, x86. Browse directory, this PC, program files x86, IntelSWTools, compiler and libraries, Windows, TBB, lib, this folder, select this folder. Click OK. Click OK. So we defined 3 variables. Now OpenCL dir. Click New, OpenCL dir. This is include path. Browse directory, this PC, system, program files, IntelSWTools, OpenCL, SDK, include. Click OK. Click OK. Now OpenCL lib x64. Click New, OpenCL lib x64. Browse directory, this PC, C drive, program files x86, IntelSWTools, OpenCL, SDK, lib x64. Click OK. Click OK. New, OpenCL underscore lib x86. Browse directory, this PC, system, program files, IntelSWTools, OpenCL, SDK, lib x86. Click OK. Click OK. Up to this point, we set environment variables. Now we have to set the path. Select path, then click Edit. New. We can put like this: Qt MSVC path %. Hit enter. New %Intel TBB path %. If it does not work, then we can fix. Okay, if it does not work, we can fix. Click OK. If it works, it should be resolved properly. I think it's working properly. Click OK. Click OK. Now start File Explorer, D drive. We are making a working folder. I will create a folder called Qt TBB OpenCL. In this folder, I will create new folder Qt TBB OpenCL. I will use it our working folder. You can create any folder. Click Start button, expand QtCreator. Right click, More, pin to taskbar. Now start QtCreator. Go to Tools, Options, select Build and Run, paste your working folder, apply. Or you can click Browse and select your working folder. Now click OK. Go to File, New File or Project, Application, Qt Widget Application. In future episode, we will also try Qt Quick Application. based on QML. Click Choose. Click Browse. New folder. 01 Hello Qt TBB OpenCL. Hit Enter. Select this folder. Hello Qt OpenCL. Click Next. Click Next. Click Next. Click Next. We will select 64-bit. I will unselect 32-bit. Click Next. Click Finish. Now select Project. Select Release. We will test with the release version first, then we will test with debug build. Click Edit. Now click Build All. Compiler output. Now click this button. Our program works successfully. Now close it. In the main window .cpp, include Qdebug. Actually, I don't think we need this, but I will do this anyway. In the profile project file, change it to C++17. We will use C++17 standard. We also need console for debugging purpose. Now in main window again, Qdebug, hello, Qt, Enter. Now press F5. Always save files before build. Save all. Now click this button. It should run successfully like this. Please note that this is very annoying. So, go to Tools, Options, C++, Code Model, Manage. Check for questionable constructs. Copy. Name it Modern C++ Programming. Click OK. Or you can just copy this script. Copy. Paste it here. Click OK. Then in Qt, select Modern C++ Programming. Apply. OK. Then the nagging message goes away. Press F5 once again. Click this button. I will close it. Now here, include talk play fun output.hpp. It complains. So open this project file, scroll down, we create, include path, $2 CppExtension dir. We also need another variable, libs. Also $2 TBB, lib, x64. We need TBB, malloc, lib. $2 TBB, lib, x64, TBB, lib. One more, dollar, OpenCL, lib, x64, OpenCL, lib. We need more include path. $2 TBB dir. $2 OpenCL dir. To link with TBB library and OpenCL library. Include path for TBB, OpenCL, and C++ extension library. Save all. Ctrl+Shift+S. In the main window again, include TBB, include CL, HPP, include talk play fun, parallel HPP. For Intel threading building blocks. For OpenCL C++ interface. Now here I will close it. std vector int bctr 1 2 3 4 5 6 7 8 9 10 auto sum up auto a auto b. Don't forget semicolon here. Return a plus b. Auto retrieve bctr auto I. Return bctr I. Auto rlta. We need to define a namespace alias. Namespace par talk play fun parallel. Now par reduce index size t bctr size int. This is initial value. Sum up. This lambda retrieve. We can create here a string too. Talk play fun ss stream auto plus talk play fun and there. Now scroll down. Stream sum from 1 to 10 rlta plus. Now press F5. It built successfully. So the result is displayed here. Reduce index is a parallel algorithm based on C++ 17 parallel algorithm. I will talk more about this algorithm in some future episode. Now or partial sum. We'll just capture all or just VCTR or range or value. Don't forget semicolon here. For or I range begin I not equal to range end plus plus I value VCTR I return value or add up or A or B return A plus B. In some case we can say constant or A, constant or B. Let's try it if it works. Or RLT B, TBB, parallel, reduce, TBB, blocked range, size T, VCTR, size. Int, this is initial value, partial, sum. This lambda, add up. This lambda. String, sum from 1 to 10 is RLT B flush. Now I will modify this part. C++17. Here I say TBB. Sorry, I made a typo here. It should be parallel. Now Ctrl Shift S, save all. Click this button. Now it builds and runs successfully. So reduce index, the parallel algorithm based on C++17 standard works properly. Also, parallel reduce based on Intel threading building block works properly. I will close it. Sorry, I decided to copy and paste some code because this code is not important in this episode. I will just copy and paste it here. This part tests if OpenCL driver works correctly. Ctrl Shift S to save all. Click this button to rebuild. So our OpenCL driver loaded and runs successfully. Now select project, build configuration, debug, edit, run this button again. It should fail. The link cannot open TBB debug lib. Open this file. I will hide it. We have to use conditionals like this. Release. This is for release build. Now debug. Copy, paste. In case of debug build, it should be debug and it should be debug. Now Ctrl Shift S to save all, build again. Now it is in debug mode. It should run successfully. Once again, in release build, it should run successfully. Or we can pause to rebuild. Click this button once again. It runs successfully. Basically, you have to know how to use these conditionals. For more information about QMake, please refer to this QMake tutorial webpage. Before I filmed this video, I read this document. For example, I used this syntax. In case of Windows platform, we can also use Win32. Win32. This should also work. Ctrl-Shift-S. Save all. Then build and run. Also note that using OpenCL with Qt, in this documentation explains OpenCL using Qt. As you can see, this document was prepared April 07, 2010. This documentation is very old. One benefit is that it is cross-platform. That means it can support not only Intel CPU, but also ARM architecture too. However, if we are going to use up-to-date parallel algorithms, such as Intel threading building block and OpenCL C++ interface, these combinations are the correct approach because Qt GUI toolkits are supported not only Windows but also Linux and Mac OS. Also, Intel threading building blocks are supported both on Linux and Mac OS. So once we know how to use Qt GUI toolkits, Microsoft Visual C++, Intel threading building blocks, and OpenCL on Windows platform, we can apply the same approach on Linux and Mac OS too. I understand that this episode is quite challenging for most of you. It is challenging to me as well because I haven't done it before. It was my first time trying to integrate all these tools from different vendors. If you leave questions, comments, requests, or recommendations, we can have bi-directional communication. If you don't leave comments or questions or requests or recommendations, I cannot know if you understand my videos or not. In future episodes, we will learn more about Qt Toolkit and modern C++ programming. Please subscribe to my YouTube channel. Thank you for watching.